All right, welcome everyone. Let's get the attendance and then let's get started. So I've got Tim, I've got Dan, I've got Oren or Kazi. I'm trying to look through the list, or no one yet. Okay. Vincat, we know might be absent because of flight problems. Richard, Satananda, did I pronounce that correctly?
Yes.
All right, Satananda. And while I'm doing this, be reading the announcements in the agenda to see if there are any addition. Stephen. Okay, I don't see Stephen. Song Ming. And then Dong. So Sridhar, does Dong know that know to attend these meetings now?
Yeah, but I mean, he's on a vacation, so.
Oh, he's on vacation, so we know he's not here. All right, so we're at 5. And I know that doesn't meet our quorum, right? What's our new quorum?
Majority. So so it's not yeah, it doesn't anyhow. We don't have to in the agenda. I don't see any decision making things. So I think we
right. So we can that's true. And again, we have a lot of the right people here to have the discussion. I was hoping to get a lot as well because he had a lot of thoughts about this last week, but that's okay. All right. So Arm has joined OPI as a premier member. Dongwei will be the representative with voting privileges, and it brings us up to 10 voting companies. Right. So we'll welcome him in absentia, and next week you guys can talk to him in person as I'll be on vacation. So Tim, you'll run the meeting next week. I'll put that in the announcements.
I will help him with the notes.
Okay.
Done it before. I think we can pull it off.
I'm not even worried. Wasn't even a concern. It'll possibly be better. Okay. TSC call. All right. The branding guys was updated and put in email. Sridhar, can we get a link to that? Is that link somewhere? Can we get the link? Because the PDF was attached.
Yes. I will send it in. I'll put it in the chat window in a minute.
Okay. All right. So I'll put the link in here, and the OPI template has been updated, and I put the link here. This is just reference, just an announcement. I don't want to discuss all that stuff. If you want to discuss it, go to the outreach group. And if there's some technical problem, bring it here as an agenda item. I'm going to ask Verizon to come in and present their view as potential users of OPI. They had volunteered back in February, and I think now is an excellent time to have them come in again as we're starting to settle in on some versions of reality with the set of proposed use cases, the lifecycle group work, and the API group work group. There are a number of good things there. And then our agenda is going to primary agenda today is remote DP/IPU centric provisioning and management of an edge location. So Intel and Ericsson. So Mike Lynch, Dan Daly, and Thomas Fredberg will be leading this. And then let's save 10 minutes or 8 minutes at the end just to verify so that Paul can verify. Or Paul, do you think you can do this in 5 minutes? Or
oh, you mean what we need for?
Yeah, actually, let's just say, what do you need from people? I mean, I copied the chat here, but what do you need from people?
So what I need to know who's going to speak during this half-day session. I'd like this group to kind of define what are the 4 sessions we'd like to have discussed for 40-minute sessions. I'm thinking one would be a demo, maybe an overview discussing what the different work groups are working on. But it needs to be more technical. But I want this group to kind of figure out what are those 4 discussions we want to have, 4 topics we want to have in our half-day session. Who's going to speak at them? And then that person would be on the hook to get me an abstract for their 40-minute chunk by noon tomorrow, so that I can put it all together and get it off to SmartNIC Summit folks.
Okay. So I propose we do this by in the Slack.
I'd say yes, but I've tried that 4 times.
Doesn't work.
And it hasn't
we
worked
haven't
yet.
got any. Okay.
I just, it needs to get done, and I'd like to get it done. So even if we just took the time today to put the topics and the speakers for each of those topics together, I'll cobble together an abstract. It really doesn't, as long as we've got something to submit, I think that would be better than nothing. But yeah, the Slack has not worked for us yet.
Slack hasn't worked. Okay. Yeah, I mean, the problem is, I mean, all right, let's see if we'll use whatever time we have at the end to start that. But again, we may have to do it by the mailing list or Slack, because I want to give enough time to the Intel Ericsson presentation.
Okay.
And so if you have the beginnings of an abstract, I think it might be easier for people to fill in. I don't know, maybe we can do that by email, because it's a little easier to do formatted text by email. And
Okay.
so if you started it and then put, brackets or something where you need filled in, then we can start an email chain, and just everyone can just type, and we should be able to be done pretty quick. So if you started it, I mean, I can type in at least part of the text. I know Mark can. I can ask Boris to as well. I know that Samir, was ready to type some stuff in. So if you give us the structure, we can fill in kind of the technical sentences. Is that okay, Paul?
Sure.
I mean,
that would be fine.
Worst case, I'll help. Worst case, Mark and I'll help you type everything in by noon tomorrow.
Sounds good.
Okay. All right. So start that email. Let's just do it by email first, and you can do it in either the outreach or the TSC list. Do it on the outreach list, and we'll. Okay. All right. Excellent. All right. Anything else? Any other agenda items? Any other general announcements, or any other open questions from anyone before we dig into the meat of the call? Okay, I'm going to stop sharing. Take it away. Oh, there's a chat. Oh, that's okay. Excellent.
Okay.
So I'll paste that in. Okay, thanks, Reader.
Thanks,
Okay.
Joe. Can you hear me?
Yes, sir. I'm going to stop sharing. Go ahead and share.
Let's see if I can share this. Okay. Let's share this. Okay, tell me if you're seeing a presentation.
We are.
Great. Okay.
We're seeing the presenter view, if that matters to you, which it might.
Oh, let me fix this. Do I do this? How's this? Better?
Perfect.
Okay.
Yes. Better.
Excellent. So thank you, everybody. And thanks for the time today, TSC. Appreciate it. So today, a few of us are going to present out on what we call remote trusted management of IPU, DPU-based systems. So it'll be myself and Andre and Kirill from Intel and Alok from Ericsson. And we've divvied up the presentation between us. So I'm just going to do the introduction. So, so from the point of view of Intel and Ericsson, we've been working on IPU POC for a while now. And as part of that, we've been collaborating and working on several use cases. You see them there. with telco edge networking for Kubernetes. We actually brought that into OPI and presented out on it a few weeks back, and now we're starting to work through the upstreaming process for that particular use case. Today we're going to talk about remote manageability, and we'll go into that. And also we're working on end-to-end network security. So that could be something in the future, hopefully at a future point in time, we'll present out to OPI as well. So today we're going to give you an overview and a demo, short demo, of remote trusted management of an IPU, DPU-based system, which can, as for example, be at an edge location, such as an on-prem enterprise location, or potentially a remote telco edge location. I mean, they're notably characterized by being untrusted in nature. The use case focus is remote management with a simplified installation process. So what that means is that, it will give you a trivial order, delivery, and installation process direct from a server OEM to the end user. And secondly, the CSP, which can be a comm service provider, or indeed even a cloud service provider, and the CSP would manage the generic IPU-based system remotely based on a secured connection following the establishment of trust. There's two main technical enablers for this. The first is you have to have IPU and DPU-centric workflows for initial boot up and secure management, and we'll take you through the why and the what of that. And secondly, management and data plane traffic separation takes place over a shared external physical port. And we often refer to this as an in-band communication mechanism. And again, we'll describe this in detail. So that's what we're going to go through. So let me hand over now to Alok on the Ericsson side, and he's going to start us off with an overview of the system architecture.
Yeah, thank you, Mike. So I should maybe if you can stop sharing and I can present the slide deck.
Off you go.
Thank you. Hope I'm sharing. So yeah. So now I would like to present the system architecture for the remote management of a single server scenario. And that includes the in-band management support, like Mike was mentioning about running the management and the data plane traffic on a common shared external interface, and that I'll go in detail. So this is an overall picture showing the various components into play for this remote single server target scenario. If I start from the top, the OEMs will deliver the IPU-based system to the customer location, and in parallel, it sends the identity-related information, for instance, the IPU ID, reference measurements, various key pairs, certificates, which we will be covering in detail in the coming slides, to the voucher type service, as that's the name we are often using in the secure ZTP type of a discussion, or as we calling it, trust establishment and attestation, aka TIA. Server's IPU identity database, so that will hold all this information provided by the OEMs, like the identity of the device and the measurements and the key pair certificates. That will be used for the trust establishment, the initial trust establishment, basically. Yeah, so other than that, we have various different enterprise services like DHCP, DNS, NTP, and these are being used for IP address assignation and DNS endpoint resolution, right? And then talking about the connectivity, we have the secured VPN tunnel, one from the IPU to the TIA or the voucher type service. This is more of an initial interim connectivity establishment for the trust establishment. And there is another one, the second one between IPU and the CSP, the comm service provider. which is rather more persistent one for handling the remote lifecycle management over this external 100 gig port, which will support the in-band management as we have been discussing so far. Then we have the Redfish server running on the IMC, which is the NIC BMC, as we often call it in the lifecycle group, and the host BMC, which is also running the Redfish server. And there will be a corresponding Redfish client running on the comm service provider side. And this will be leveraged for performing the remote attestation. So CSP asking for the Redfish schemas for attesting and identifying the identity and the trust establishment and the attestation for those devices. And we have an exciting demo explaining all these concepts, a quick demo around these concepts that I'm talking about. Also, we strongly believe in the gradual trust establishment following the IPU DPU centric workflows, where the root of trust is residing on the IPU DPU device. So which makes it more of a central component in this overall initial boot and secure management, right? And in this diagram, we are, as you can see, using different color codes. So the region shaded in green is the trusted domain, where we have the root of trust establishment following the IPU-centric approach, whereas we have this motherboard BMC in the host OS, which is initially belongs to a untrusted domain for the initial setup, and it's, as it's shown, denoted by a random color. Yeah. So, and then there is a secure channel between the IPU and the motherboard BMC. You can choose an option to connect over the 1 gig port, or we can also connect using the NCSI channel that can provide the same speed of 100 gig as for the external link, and that is providing the in-band management. And I would like to emphasize that this in-band management is meant for the external connectivity, and there is no such separate connectivity for accessing the motherboard BMC. Therefore, both the management as well as the data booking traffic will be sent over this port, and we will make sure the end-to-end traffic separation should be enabled for the security reasons. Okay, so following that, we have the trust establishment. As I talked about the gradual trust establishment, then the host BMC trust establishment and provisioning can occur after the root of trust establishment over the IPU, and once the IPU device has been provisioned successfully, right? And the motherboard BMC provisioning could include the BMC firmware, software upgrade, and that can be instant initiated after, like I said, the root of trust establishment over the IPU. As you can see in the diagram, we have different consoles. The remote consoles can be accessible from the CSP on the IMC, on the ACC level, as well as the motherboard BMC and the host OS. So we have the various different remote consoles that will be accessible from the remote CSP, and that can be used for provisioning and even for troubleshooting or for normal operations, like performing the software upgrades, for instance, for the BMC firmware. Okay, so that's all about the overall architecture, and let's switch our gears to talk about the device provisioning and the attestation workflows, where Andrew will take us through the different steps and the workflow. So let me stop sharing and go over to you.
So can we ask any questions at this point?
Yeah, of course.
Yeah, so
let me-
on the diagram that you showed, you have the root of trust being in the IPU, but a lot of the servers that are out there also have a root of trust that's built into the overall server platform itself. is there a joint attestation aspect to this where each of those root of trusts will have to understand and essentially validate one another? So you kind of have a joint root of trust between the two entities?
I think it's more, this is Thomas Fredberg also from Ericsson. I think it's more a matter of that it enables the gradual buildup of trust from the outside. So it's not a decision on that you need to bring everything into one and only one trusted entity. It's about enabling the remote trust in all the different pieces. So we haven't worked out if it needs to be that you're sort of getting the IPU to start trusting the other ones, or if you're only opening up the consoles, the ports through the secure VPN tunnel and letting the BMC be trusted over the remote link or not. We're not at that stage.
Okay, so this could generally lead to a distributed root of trust that needs to also be considered in the architecture. Okay.
Yeah, and like all of the things in this presentation, what we want to hear at some point is what are the OPI components that are going to come in, or modifications that we may need to be made to the existing OPI components, and what is always going to be a kind of a vendor component as opposed to an OPI defined component. And again, it could be a specified or it could be actual open source code. And I'm sure you guys are going to cover that, but just as a reminder, that's something we definitely need to hear here in this TSC call.
I mean, not in detail, but I think
no, just all we need right now is directionally, because you can come back with a concrete proposal later, but directionally, that's kind of what we need to know whether this is a good direction or not. I mean, I like these ideas, but to know how this relates to OPI is critical.
Yeah. So I think we have certain commonalities what already exist in OPI, specifically in lifecycle group. Like there we have the voucher type service and bootstrap.
Sorry, I didn't mean to completely derail you. Go on the tracks you've already laid down, get all the information out, and then at the end, let's come back and talk about that, and then figure out how we create a proposal that says, here's what we need from OPI. Here's what we're going to contribute to OPI. Here's what we'd like other people to do. Let's do that as the next steps and plan to go with this idea.
Maybe I can highlight at the end about what's expected from the OPI community and where exactly we can contribute in the discussion.
What are you going to contribute? What do you expect? And then, what's the plan to get there? And if we don't have a plan yet, that's fine. We can work on a plan jointly. That's one of the purposes of the TSC among many others. So please proceed on your track. I want that in everyone's mind as we go along. All right, thank you. Please proceed.
Thank you. So continue, Andrew, please.
Yeah, let me share. Okay, can you see my screen now? Yeah, okay, good. So let's start with initial device provisioning. So in our case, how system looks when it just delivered on site and prepared to be powered on. So, and we will see picture like this. On left side, we have a server with IPU, DPU. The server is connected to power, connected to network. It's ready to boot. We have this online status indicator. We will change color corresponding to what stage it is. And I think what's important to highlight here on the server, as we can see on IPU, we have some voids. We don't have, for example, image to run on IPU, CPU cores, IPU or GPU, whatever. It does not know anything about who it belongs to. There is a it does not know how to connect to owner, but what it knows how to connect to our voucher server or TIA. Of course, there is some measurements which collected during manufacturing. There is a private key to sign it. For example, SPDM, if we use SPDM mechanism. And as you can see here, there is nothing installed on operating system on host itself. So what we have generic, the latest, whatever manufacturer can install. We have generic software on BMC and on IMC or NIC BMC. On other side, on remote, we have our voucher server or TIA, again, which in IPU identity to corresponding serial number, it stores again information about measurements, its certificate to connect to it, and also stores information about who this system belongs to. And on owner, in our case CSP, it's very similar. Of course, there is nothing to do with T. It has no any certificates about T, but what it has in addition to that, it has a database of images that will be used for deployment, update, upgrade, and so on. And this cloud between server and remote could be private, could be public. We don't care. It's just a connection. And we said that we use secure connection. For our demo today, we will show how we use it over WireGuard terminated on IMC. And for Redfish server, again, it's not a full-fledged Redfish server on IP. We're just using standard open source DMTF Redfish mockup server, which enough to show us that we can run it, we can connect to it, and we get some information. But because it's a mockup, it does not support post actions. So again, the certification, it's just attestation, it's a simulation. But in future, if we have Redfish server enabled, real Redfish server, then we can use already defined standards like component integrity action in Redfish or SPDM get signed measurements can be used for attestation. Okay, so this is our initial state. And now we can look at how system starts. Again, assumption is that after we install it in enterprise network provides basic services like DHCP, DNS, NTP, and then how it connect to network using NAT firewall. So this is by default provided by enterprise. We don't touch it, we just use it. So let's see how it happens. We start with power on our system. While it powers on, we collect measurements. We can collect up to, on Intel IP, we can collect up to 6 different measurements. So then we start to use local services like DHCP to get a IP address, NTP to get local time or current time. And now we can use DNS to get IP address of our TIA. After that, we can start our connection. So we use here we again, as I said, we're using WireGuard for mutual connection. It could be MTLS, for example. After that, remote TIA server can start and prepare this component integrity action for Redfish. And then it will use SPDM get signed measurements procedure. It will sign measurements collected during boot. And then the signed measurements will be sent over. So voucher server can use its own key and confirm that it's a trusted system. And now, after system is attested, it can deploy to IPU certificate for connection plus name, how domain name of the system, of the owner of this IPU. So at this stage, as you can see, we fill this void. We know the owner, so now we can connect to owner. So what will happen? Our online indicator status is okay. It will change to yellow, saying, okay, I already know who owner is. Now I'm starting to talk to it. And then it can disconnect from TIA, start connect to CSP. It will do same stuff again about attestation, system attested. And now after system is attested at CSP level, CSP will deploy image for IPU course and boot it. So at this stage, we have IPU fully provisioned and functional. So we can change our online status between yellow and green. Why it's not fully green? Because as you can see, we still have void on host. And actually, this is next step for us. And it's a good overlap actually with OPI lifecycle. It's what we're discussing right now for last couple of weeks is our how we can synchronize boots of between host and IPU. So next step will be defined after we can hold host how we can hold operating system on host before we deploy through IPU. I think this is very important step for us. But even without operating system on host, we already can start our communication. So we can use clients to connect to different consoles. We can use Redfish client to, again, to install some on provide something to BMC server, credentials, and so on. And we, at this stage, we're ready for data plane traffic as well. So it was manageability only. Now it's a data plane. But as I said, for data plane, we need a host be up and running. But let's see actually how we can implement in this mechanism, how we can implement our manageability and data plane separation internally as well. So what we have here, because we use our same physical ports for both management and data plane, how we envision it and how we're implementing it right now in this prototype and demo, we have separate VPN tunnel to BMC. So manageability VPN is terminated here on BMC of NIC or IMC in our case. And after that, we use our internal network. All these green lines, they indicate internal network. And then we can use very simple DNAT to, after we terminate tunnel, to send traffic to whatever we need to BMC, IMC, or ACC. And actually, as a fallback mechanism, we can use some virtual connection provided by all currently, like modern BMCs. They usually have a connection to host using a virtual channel or virtual console. Same we have for our IPUs. So if something happens with network, for example, I don't know, somebody put an interface down on host, we still connect to it through our mechanism. So we can connect to BMC or NIC BMC, then it will connect through this connection. We can pass it through to BMC and then BMC connect to host. And data plane traffic, which is black here, we sharing ports, but we not sharing any security or VPN. I mean, we have a separate VPN for manageability, and data plane traffic can work completely on a different, like IPsec or something else. We don't overlap. So this is, again, both networks completely independent, can use different encryption mechanisms, different tunnels, and so on. And now I will pass screen to Kirill, and he will have a quick demo of initial boot up of the system. Kirill, floor is yours.
Okay, thank you, Andrei. Okay, so here you can see 4 panels. On the top row, on the left side, it is IMC serial console, and on the right side, ACC serial console. In the real life, these consoles are not connected to anywhere and are not visible by anyone. So we just present them for the demo purposes. On the bottom row, we see the tier SSH window and the CSP SSH window. So, and now we will start our demo. First of all, we start on the tier. We will start tier script simulating the tier service, and on the CSP console, we will start the script simulating CSP service. And then on the IMC serial console, we will start script which will issue a hardware reset to IMC, which will actually simulate the power on conditions. After reset signal is released, IMC starts, first of all, a U-boot loader, which does initial configuration of the system and then loads the kernel. After the kernel started, we do some scripts, perform some scripts which will do configuration of different components of IPU, like network component and some other. And after that, it will look up for the DHCP server to obtain its own IP address. And then once it finds the DHCP server and DNS server, it will get discover IP addresses for NTP and other servers, and for instance, for the tier server. Once it gets the IP address for tier server, it will send the provision request to tier server. And once tier server complete the provision, it will provide IMC with credentials for do connection to the CSP server. At this point, IMC will close the WireGuard channel to the tier server, and using these credentials, will open secure WireGuard channel to the CSP server, and again send requests to do the attestation. Once attestation is successfully complete, CSP server using this secure WireGuard channel will provide IMC with images for the ACC. And once IMC get these images, it will issue a boot signal to the ACC. And now ACC boots its operating system using the images provided by CSP server. And at this point, all components of the IPU are up and running, and basically IPU is operational and ready to be used. Thank you, Andrei.
Yeah, thank you, Kirill. And now I think it's back to you, Alok.
Yeah, I think we can continue with the same screen. So yeah, thank you, Andrei and Kirill for the demo. So we discussed some of the important concepts and saw the quick demo about how we can provision initial boot up the IPU or DPU through the remote management and what we call CSP, the comm service provider, right? So we leveraged the voucher type service, or the TR as we calling it, for the remote management, initial trust establishment, and it provides the OEM specific, the CSP specific certificates, right, for connecting to the CSP, which is rather a persistent connectivity for lifecycle management of the IPU DPU centric device, right? And we discussed about and demonstrated the initial provisioning of the IMC ACC, and we can use the same connectivity for performing the normal operations like motherboard BMC, firmware software upgrade, and yeah, so that can be done as well using the remote connection establishment with the CSP. We also discussed about the in-band management, right? The same physical Ethernet port used for the management traffic as well as data traffic in totally separate traffic separation for security reasons, and that's doable in light of the in-band management support for the IPU DPU devices. And with that, I mean, there are a couple of next steps, and like it was mentioned in the beginning. So what's the expectation from the OPI? So today, I think most of the discussions, specifically in the lifecycle subgroup, right, are heavily based upon the out-of-band management, or with the assumption that if there is no NIC BMC, or in this case, the IMC type of a device is not present. So what we are like asking this group is maybe having the similar discussions, the one which is happening currently in the lifecycle group, or the future proposals should include the concepts of the remote management through the remote CSP type of a server doing the full lifecycle management of the device, following the gradual trust establishment using the IPU DPU centric approach also, and that makes motherboard the NIC BMC as part of the central component, because that will be establishing the initial trust and the attestation flows. So I mean, these are some of the expectations, and we are happy to contribute and take the discussions to the next level to make it into specifications. Yeah, I think that's the ask from the group to consider those type of scenarios and in the current and the future discussions. Yeah, I think that's all from my side, and I think we are done with the presentations. Any comments, questions from the group?
Right. So given the work you've described here and the set of components you've described here, again, what we need is a list of the existing OPI components and services that will be used for doing these things. So how does secure ZTP fit in, for example? Will this need any modification to the boot sequence? Do we need to define a non-boot host BMC to IPU DPU BMC communication mechanism, or adopt one? Do we need to define how Redfish servers get embedded in a common way for OPI? What we need is a list of those things with a little paragraph or some bullet points describing them, and maybe a lot of paragraph and bullet points for if there's subtlety describing the interaction. And then what new elements here are going to be contributed to OPI? So is the root of trust establishment itself in this kind of multi component root of trust, is that something we have to define because the IPUs sit in a different, almost in a different boundary, but people want to think of it as the same boundary for trust? And I mean, we need a proposal for, hey, what's going to get brought in, rather than having the wider group try to guess as to what we should do and say, okay, bring that in, bring that in, bring that in. Because if you ask me that, my first opinion would be bring it all in, make it all open, bring it all in. But I know there are some lines there that probably are not a good idea, which is why we need the explicit proposal as the next step. This was a great overview and a great intro.
Yeah.
I don't know. Anybody else have thoughts, or respond to that, and then we'll see if anyone else has thoughts or questions or opinions.
Yeah, Joe, I have one comment that
Yes, please.
the provisioning lifecycle group has a coordination pull request they're working on, and itemizes the different situations 1, 2, 3, 4. So I think as far as we've gotten, and 4 is not filled in, and 4 is the mutual BMC problem or use case, which is what they're asking us to work on. So it's there in our list. And it just hasn't, Boris just hasn't gotten to it yet. And in fact, he was asking questions in Tuesday's meeting as a lead-in to talking more about the mutual BMC problem between the host and the IPU. And discussing what's the communication channels between those two.
Right. So is there based on this work, is there a concrete proposal that could be put forward to say, here's how we think it should work? And then again, we have both this call and the lifecycle and provisioning call, and in fact, the API call, all of which can be used to review this, right? We don't have to restrict ourselves to just one of the calls for these kind of meta services, I'll call them.
Yeah, my ask would be to have this team, the Intel Ericsson team, come to Boris's meeting, get a 30-minute spot there or longer, and let's talk about it from their perspective and what they need that number 4 to look like, or what they're proposing it to look.
Yeah, the proposal for that 4th case, as you're saying, Tim.
Yeah.
So I have on the overall proposal here is that it sort of skips over or makes this huge assumption that the IPU is shipped with the final stage, all correct, fully measured firmware. And mostly from the lifecycle group, we've assumed that's not the case, and that the very first thing you need to do when you get on the network is go out and find your image and re-image your firmware. And I don't see how that is covered in this demo. I see more of an assumption that it's all correct at the day it ships.
Yeah, actually, Tim, we don't have it here because what we said when we provision, our IMC has a current generic image, which knows how to connect to T and how to get credentials to connect to CSP. And yes, in our demo, we just shown that we fill in this ACC void when we connect to CSP, but nothing prevents us to start, of course, first to get these measurements, get versions, and first update IMC if needed. And actually, to be honest, in real life, it probably will be needed step, because if CSP now owns this device, it probably will add some extra services or update to upgrade to map with their functionalities they need. So yes, we just keep this step because we have a generic image which will be replaced or updated by CSP. And actually, even during normal operation, you probably will have to do some patches, security patches, update your functionality. So
Right.
yes, it's there. It wasn't just a part of our demo, but you're right. We probably should mention it that it's also expected.
Yeah, there's the initial day 0 reprovisioning.
Yeah, exactly. So
ongoing updates.
yeah, exactly. So this is very generic image that knows how to establish secure connection, how to get attested, and after that, it's why we have here, if you look at here, like we have ACC, IMC, BMC, and operating system. So any images we need to apply to the system.
Including
to-
IPU firmware.
Yeah, including IPU, yes, both
So
like
how-
all components for IPU and for host and BMC.
So can you describe how this relates or doesn't relate to the secure ZTP that's already been voted in as standard?
Yeah, there are a
I
lot
think
of.
we have
I
a
want.
cable, right? So maybe
Yeah,
we can.
actually, yes. Just yeah, good. Sorry, look, I forgot about it. Yes, actually, here in backup, what we did actually, we even we took RFC, our SZTP, not just OPI, but full SZTP RFC, and
Yeah.
we did this mapping. Okay, terms we use in this RFC and terms we use in our presentation here.
Okay,
There are a lot of overlap. Yes.
yeah, there's a lot of overlap. So the question is, are there additions to secure ZTP that are required? And can we do an open source project that says, if you use secure ZTP as your core, here's what you get for dealing with IPUs. And but you need these additional things as evidenced by this use case. And here's the code to do those, right? And actually contribute the code to do those so that everyone can be doing the image and component update on the IPU the same way, or DPU the same way. Because that's I mean, if we got to something like that, then I think, I mean, at least I'm all for all this, because that's enhancing OPI overall and putting standards in place where we know we have to do the things you say. I mean, there's no question that the use case and the workflows you described are both interesting and necessary.
No, right. And actually, we have work in progress right now, like as we speak. We use all this SZTP OPI, what Boris actually created, all those images and so on. And we working on recreating it on IPU, on this system. So we can make this comparison and say, okay, this is a gap we need to address in OPI, or this is a gap we can contribute to OPI to fulfill.
Yeah. So can we get that list?
As I said, we're working on it on this SZTP installation. Yes, sure, exactly. So we're not doing it just for us internal. No, this is what we're doing it. We want to collect this data and then share it with OPI and discuss it, upstream it, provide all feedback we collect during this.
Excellent.
Sure.
All right. So the next steps are to basically start producing the set of things that OPI needs and what's going to be provided by Intel and or Ericsson, and then what is needed from someone else, and then what in these scenarios will not be contributed and why it won't be, why that ought to stay, I should call it solution or vendor proprietary, because you don't get any value out of open sourcing or standardizing it. In other words, you see what I'm saying? So what we need is the breakdown of the components and what comes into OPI, and we ought to manage as this group, and what stays outside of OPI but then uses OPI components, and which components explicitly get used, other than sort of generic stuff like OTel for the television. You don't have to talk about that, but talk about the kind of the directly related components that get used and how they integrate. Because I think that list would help anchor for everyone. I don't know if anyone has a different opinion, or if you don't think that makes sense, then alternate proposal is great.
Just to add to that, I think, like Andrea was mentioning, I mean, there are certain commonalities and overlap, but it already exists in the secure ZTP, and we have that captured in this table. I think first of all, the logic thing. And I think what the main highlight in this discussion today is about the remote management. That's not being captured in current specification, how the owners can fully lifecycle manage using the IPU DPU centric approach, like building the root of trust on the IPU DPU device first, and then do the first, for instance, the BMC motherboard BMC normal operations like software upgrade or the host OS firmware software upgrade, those type of things. So I mean that part of is kind of missing today from the secure CTP. I think there we can contribute and bring up some.
Great. Okay, so I'll look for the beginnings of that list, either as a markdown file, or I guess you could do it by email and put it in our online repository as a Word doc or a deck. So we'll start looking for that list, and we'll go from there. But this was a great intro and overview to all of these components and aspects. This was excellent. Thank you. All right, we're going to terminate the meeting. It's at time, and Tim will run the call next week. See you guys in 2 weeks.
Joe, just
Yes, sir.
at the very end, I put the link for that doc that I started on the agenda for Smart Next Summit.
Yep.
So maybe if you want to put that link in the notes, that'd be great.
I'll put it in the notes, and then send it to the Lifecycle and the TSC mailing list as well.
Yeah, I'm sending it to the mailing lists.
Okay, thanks, man.
Thanks.
Bye-bye.
Bye.
Thank you.
Thank you.